Hey folks, all good? We know that we are small, or even smaller than a grain of sand in the universe, and yet we have our giant planet Earth, with unexplored places by humans, like the ocean, for example. We have only explored 10% of it so far, with ecosystems untouched by humans. And that's what today's video is about, ecosystems unexplored by humans. Shall we dive in? Hydrothermal vents on the ocean floor. Hydrothermal vents are openings in the Earth's crust on the ocean floor, where geothermally heated water emerges, often rich in minerals. These unique environments are found on ocean ridges, where tectonic plates separate and hot magma rises to the surface. The water emerging from these vents can reach extreme temperatures, often exceeding 300 degrees Celsius, and is laden with a variety of minerals, including metallic sulfides. These ecosystems sustain a surprisingly diverse life, including bacteria, archaea, tube worms, mollusks, and crustaceans. Energy in these communities is derived from chemosynthesis, a process where organisms use inorganic chemical compounds to produce energy rather than photosynthesis, as is common in many other ecosystems. Hydrothermal vents on the ocean floor are extremely important ecosystems for understanding the origin of life on Earth, and may provide insights into life on other planets, such as Europa, one of Jupiter's moons, which has a subsurface ocean beneath a thick layer of ice. Subaquatic caves. Subaquatic caves are cave systems that extend beneath the water, often in coastal areas, where erosion by seawater creates complex networks of tunnels and chambers. These ecosystems are notable for their complete darkness and their diversity of life adapted to subaquatic conditions. In subaquatic caves, one can find a variety of organisms, such as blind fish, shrimp, crabs, as well as unique geological formations like underwater stalactites and stalagmites. These environments are challenging to explore due to the lack of natural light and the need for specialized equipment such as flashlights and diving gear. Subaquatic caves represent fragile and vulnerable ecosystems, susceptible to disturbances caused by human activity such as pollution and uncontrolled tourism. Therefore, research and conservation of these environments are essential to protect their unique biodiversity and scientific value. Submerged forests. Submerged forests are aquatic ecosystems where trees and plants are submerged in fresh water or salt water, often due to changes in sea level, flooding of coastal areas, or natural events such as landslides. These environments are found in lakes, rivers, estuaries, and coastal areas around the world. Submerged forests provide important habitats for a variety of aquatic organisms, including fish, crustaceans, mollusks, and waterfowl. Additionally, these ecosystems play a crucial role in nutrient cycling, coastal protection, and maintaining water quality. Submerged vegetation, such as algae, aquatic grasses, and mangroves, is adapted to aquatic conditions and plays a vital role in the health of aquatic ecosystems by providing food, shelter, and habitat for a variety of species. However, submerged forests are facing increasing threats such as habitat degradation, pollution, and climate change, highlighting the importance of conserving these valuable ecosystems. Before we continue, please, if you enjoyed the content, help me by subscribing. I really want to grow on YouTube and promote knowledge. Deep ocean canyons. Deep ocean canyons are underwater geological features that resemble terrestrial canyons, but on a much larger scale. These formations are found on continental shelves and submarine slopes, where submarine erosion processes carve out underwater ravines and gorges. These ecosystems are notable for their biodiversity and the presence of unique marine communities, including corals, sponges, fish, crustaceans, and other marine organisms. Deep ocean canyons also play an important role in nutrient circulation and connectivity between different marine habitats. Deep ocean canyons are underexplored due to their depth and difficulty of access, but recent studies have revealed new species and unknown ecosystems in their depths. These underwater environments are vulnerable to destruction caused by human activities such as bottom trawling and mineral resource exploitation, highlighting the need to protect and conserve these valuable ecosystems. Subglacial ice deserts. Subglacial ice deserts are vast expanses of rock and sediment devoid of ice beneath the ice sheets of Antarctica and Greenland. These unique environments have been isolated from the outside world for millions of years and offer insights into the habitability of extreme environments and life on other icy worlds. Despite the extreme conditions, subglacial ice deserts harbor a variety of microorganisms adapted to cold and dark environments. Recent studies have revealed active microbial communities in subglacial sediments where energy is derived from chemical processes rather than sunlight, as in photosynthesis. Understanding subglacial ice deserts is crucial for understanding the functioning of glacial ecosystems and their role in regulating global climate. Additionally, these environments may provide insights into the possibility of life on other icy bodies in the solar system, such as Mars and the moons of Jupiter and Saturn. Methane seeps on the ocean floor. Methane seeps are structures on the ocean floor that release methane gas, one of the major greenhouse gases. These ecosystems are found in areas of submarine volcanic activity, where methane is produced by geological processes and released through fissures in the Earth's crust. Methane seeps support communities of organisms adapted to life in hydrocarbon-rich environments, including bacteria, archaea, worms, and mollusks. These organisms perform chemosynthesis processes to obtain energy, using compounds present in methane and other hydrothermal fluids. Recent studies have revealed the presence of methane seep ecosystems in various regions of the ocean, including the Gulf of Mexico, the North Sea, and the Pacific Ocean. These environments are important for understanding methane biogeochemical cycles and their role in global climate change. Subterranean lakes. Subterranean lakes are bodies of water that form in caves or underground tunnel networks, often in karst regions where erosion of limestone rock creates empty spaces. These ecosystems are characterized by their complete darkness and lack of connection to the surface, creating unique conditions for subterranean life. Subterranean lakes harbor a variety of organisms adapted to darkness and isolation, including blind fish, crustaceans, mollusks, and microorganisms. These organisms often exhibit distinct evolutionary characteristics, such as loss of pigmentation and vision organs, due to the absence of natural light. Despite their inaccessibility, subterranean lakes are ecosystems vulnerable to pollution and degradation caused by human activity, highlighting the importance of conserving these fragile environments. Scientific studies in subterranean lakes can provide insights into the ecology and evolution of subterranean organisms and help to better understand the geological processes that formed them. These 7 unexplored ecosystems represent only a small fraction of the vast diversity of habitats that exist on our planet. The exploration and research of these environments are essential to expand our knowledge of Earth and its life, as well as to provide valuable insights for the conservation and sustainable management of natural resources.